Hello again, everyone. This is Mr. V. Hill, and today we're going to be talking about how to solve radical equations. And we're just going to do two quick examples. Should go pretty quickly here. First example, we have here the square root of 2x plus 3 is equal to 5. Now we can't just start solving or undoing what's being done to the variable x right now because it's trapped inside of the radical. So we need to first get rid of the radical. And of course, how do we do that? Well, we just square both sides of the equation. So we put a square there and a square there. If two things are equal, their squares are also going to be equal. And so the square of the square root, those cancel each other out, leaving us with 2x plus 3 is equal to 25. Okay. Now keep in mind also that this square root, it does not have a negative symbol in front of it or a plus or minus in front of it. So again, we're only talking about the positive square root here. But now we just got a simple linear equation. We know how to solve that. Subtract 3 from both sides, of course, leaving us with 2x is equal to 22 because those cancel each other out. And then we just divide both sides by 2. And those cancel each other out right there. So we're left with x is equal to 22 divided by 2, which is, of course, 11. Now, don't forget to check your solution as well, meaning we plug it back into the original equation. So we check this by asking ourselves, is it true that 2 times 11, the square root of 2 times 11 plus 3, is that actually equal to 5? And while 2 times 11 is 22, add another 3, that's 25. So the square root of 25, notice a positive square root as well, because there's nothing out front. That does equal 5. So yeah, we did it right. Pretty simple so far. Let's try another example here. We'll call this one example 2. Let's say the square root of, let's say, oops, not that, sorry. Square root of x plus 5 is equal to, let's say, 2x. Okay, so again, we're only talking about the positive square root here. So first off, we have to square both sides of the equation. Keep in mind, we're squaring the entire side of the equation there, not just the x. So now the square of the square root, those cancel each other out. So now we have x plus 5 is equal to 2x. Excuse me, 2x squared, which would be 4x squared. And so now we really have a quadratic equation. So to solve a quadratic equation, we need it equal to 0 on one side. So we're going to subtract the x and subtract the 5 from both sides. So first subtract x, getting rid of those. So we have 5 is equal to 4x squared minus x. And then, of course, we just subtract 5 from both sides. Those cancel out, leaving us with 0 is equal to 4x squared minus x minus 5. Now, we could factor this or use the quadratic formula or complete the square, however you like. I'll just use the quadratic formula really quick here. A is 4, B is equal to negative 1, and C is, of course, equal to negative 5. So we plug that in now. X is equal to the negative of B, should then be a positive 1, plus or minus the square root of b squared. The square of negative 1 is 1. Minus 4 times a, which is 4, times c, which is negative 5. All divided by 2 times 4. So x is equal to 1 plus or minus 0, 1. Minus, we're going to be a negative here because we have this negative 5. 4 times 4 is 16, times another 5, that's 80. So this is the square root of 81. all over 2 times 4 is 8. Or now x is equal to 1 plus or minus square root of 81 is, of course, 9 over 8. So that means that x is equal to, well, 1 plus 9 would be 10, 10/8, which would be 5/4. Or x is equal to 1 minus 9, which would be negative 8, divided by 8, which would be negative 1. Okay, so supposedly we have two solutions to the original equation. So let's plug them back in to check. These two solutions. So let's see here. So we go back to the original equation and we ask ourselves, is the square root of 5/4 plus 5, is that actually equal to 2 times 5/4? And 5/4 plus 5, let's see here, 5 would actually be 20/4. So this is the square root of 5/4 plus another 20/4 would be 25/4. Is that equal to 2 times 5/4 is, of course, 5/2. And yes, the square root of 25/4 is, of course, 5/2. Very good. So that's one solution. So this one definitely works, the 5/4. And let's check the other one, the negative 1. So is it true that the square root of negative 1 plus 5, is that actually equal to 2 times negative 1? And so negative 1 plus 5 is, of course, 4. Is it true that the square root of 4 is equal to 2 times negative 1, which is negative 2? And oops, no it's not. Look at this, we're talking about the positive square root of 4, which is 2, not negative 2. So that one doesn't actually work. So what that means is that this solution is what we call extraneous. Meaning that it is a solution to the equation when after we square both sides, but it's not a solution to the original equation. And that happens oftentimes when we have a linear on one side, 2x, and the square root on the other side. It turns it into a quadratic, and oftentimes that brings up an extraneous solution. So let's see what's actually happening here. So let me clear this out. So if we graph these things, if we graph the square root of x plus 5, then also 2x, because that's what we're really looking for here. We're kind of finding the intersection of the function y equals the square root of x plus 5 and y equals 2x. So if we look at the intersection points of those, there's the square root, and there's my linear. And notice here is one solution, the intersection of these two. That's the 5/4. This solution of x equals negative 1, well, that would occur if this sideways parabola continued on around on the bottom side. We would have another intersection point when x equals negative 1. But since we were restricting ourselves to just the positive square roots, we don't actually have another intersection point down here. And that's about it for solving radical equations. Pretty simple. See you all in class.